Today, we're talking about something that honestly sounds like it's pulled straight from science fiction. It's called QED Nano, and it's a tiny AI that can reason like a mathematical genius. And believe me, this could completely flip the script on how we think about artificial intelligence. So let's just start with the big question, right? Can an AI really have a eureka moment? That genuine spark of insight we associate with human genius. For decades, that kind of abstract reasoning has been this huge, unconquerable mountain for AI. Now, to really get what's at stake here, we have to understand the arena. We're talking about mathematical proofs. And this is not your high school calculator stuff. No, this is about building a completely airtight logical argument where every single step is flawless, leaving absolutely zero room for doubt. Okay, so that brings us to it. Why is this so ridiculously hard for AI? Well, up until now, the only answer we really had was just pure brute force. We tried to solve the problem by building giants. Think of it like this. Finding a mathematical proof is like being dropped into a maze that is, for all practical purposes, infinite. It has endless pathways, countless dead ends, and there's only one right way out. You make one single wrong turn, and you're lost. For a computer, the number of possible paths to check is just mind-boggling. So the thinking in the industry went something like this. Hey, the maze is enormous? Simple. We'll just build an enormous brain to run through it faster. The whole strategy was just to scale up, creating these massive AI models to just brute force their way to an answer. And when I say enormous, I am not kidding. We're talking about models with something like 175 billion parameters. Just try to wrap your head around that. Each one of those parameters is like a tiny little dial that AI has to get just right. So you've got 175 billion dials, and they all have to be in the absolute perfect position to solve the problem. That's the staggering scale of these AI giants.
But here's the catch. Being a giant has some serious weaknesses. These things are energy hogs. They consume a crazy amount of power. They cost a fortune to train, require data centers the size of warehouses, and basically, it means only a handful of the biggest tech companies can even afford to play this game. So what if that whole bigger is better idea is just wrong? What if the real answer isn't about being bigger, but about being smarter? And that's where our underdog comes into the story. Meet QED Nano. Just look at this. It's the classic David versus Goliath story, but for the world of AI. To put it in perspective, remember that 175 billion parameter monster? QED Nano is a tiny fraction of that size. We're talking thousands of times smaller. It's not just a different approach. It's a completely different philosophy. This is pure cleverness going head-to-head with raw brute force. Which, of course, brings us to the million-dollar question, right? How in the world can something so small be so smart? How can it possibly even compete with the big guys on a task this complex? Well, the answer all comes down to its secret weapon. See, it's not about the size of the model. It's all about how it learns. And QED Nano has a completely new way of doing that. Okay, let's walk through how this actually works. First, it learns the language of math, the basic rules, the symbols, all that stuff. Then, and this is the really cool part, it starts generating its own homework. It just makes up problems and then tries to solve them. And finally, it checks its own work. It's both the student and the teacher, constantly finding its own mistakes and getting better. It's this amazing feedback loop of learning. So here is the absolute game changer. QED Nano doesn't need a gigantic library of problems solved by humans to learn from. It literally creates its own curriculum. By generating its own training data, it becomes this incredibly efficient, self-sufficient learner. It's like a math whiz who doesn't just ace the test, they actually write the textbook too. All right, so we've got this clever little underdog with a brand new training technique. But, talk is cheap. Can it actually perform when it counts? Well, it's time for the main event. And this was not just some pop quiz. QED Nano was thrown right into the deep end. It was tested against a set of theorems that are specifically designed to stump AI. I'm talking about the kind of problems that make even the giant models sweat. So yeah, the stakes were incredibly high. And here are the results. Just look at this. On one side, you've got your standard AI model, and as expected, it really struggled. But then you look at QED Nano. Whoa, it didn't just do a little bit better, it blew the standard approach out of the water. This tiny model was solving problems that the big guys were getting stuck on. Just incredible.
Okay, this is huge. But it's not just about one little AI solving some tricky math problems. No, this points to something much, much bigger. This could be the start of a whole new era for AI.
What we're really seeing here is a proof of concept that challenges the entire status quo. For the last decade, the mantra in AI has always been bigger is better. This result just turns that whole idea on its head.
So, what does this actually mean for us for the future? Well, for starters, it shows that we can have powerful AI that's also sustainable. No more burning through mountains of energy. It also democratizes AI, opening the door for so many more researchers to innovate without needing a massive budget. Imagine powerful AI running right on your phone or in your car. That's what we call edge computing. And maybe most importantly, this could seriously speed up how we solve some of the world's biggest problems, in everything from science to medicine.
And it all really boils down to this one powerful idea. Maybe the future of AI isn't about building ever larger digital brains. Maybe it's about teaching smaller ones to think more cleverly.
So I'll just leave you with this thought to ponder. From discovering new medicines to designing incredible new technologies, what new frontiers could we explore if every device, every lab, and every researcher had access to a tiny, efficient genius? The possibilities are truly staggering.